This week on the Computer Chronicles, how to build the ultimate gaming computer. We'll talk graphics cards and show you the new NVIDIA GeForce 3. We'll talk sound cards and show you how to add stunning theater-style surround sound to your games. We'll show you what it looks like to play a game on the newest Pentium 4 chip running at a blazing 1.7 gigahertz. And the editors of Maximum PC Magazine will show us their choice for the best overall gaming computer. How to build the ultimate gaming PC, coming up next on the Computer Chronicles. Computer Chronicles is made possible in part by PC to PC, the online computer migration service from PC First, moving files, applications, and preferences from your old computer to your new one. Additional support is provided by Upside Events, presenting the Digital Lifestyle Revolution Conference, where people and technology intersect. Hi, and welcome to the Computer Chronicles. I'm Stuart Chaffee. There's some very interesting marketing data on new PC purchases, which shows that most PC upgrades for consumers are driven not by the grown-ups in the house, but by the kids who want a more powerful gaming machine. Certainly there is no more demanding application for a computer than today's graphics-intensive games. So today we are going to help you figure out how to put together the ultimate gaming computer. And we're going to start out with graphics. And here to help us do that is Tony Tomasi of NVIDIA. Hi, Tony.
Hi.
All right, so you've got the brand new GeForce 3 graphics card here, and there's a million cards out there. This is new. What is different, better? It's actually a next generation card.
That's exactly right. The GeForce 3 is the latest generation graphics processor from NVIDIA. So this product actually includes a 57 million transistor graphics processor. To put that in perspective, that's more transistors than a Pentium 4 plus a Pentium 3 put together.
Just on the graphics card?
Just on the graphics processor,
okay.
As well as 64 megabytes of 230 megahertz DDR memory.
But what's key about this is it's programmable,
That's exactly right. For the first time, the graphics processor is as programmable as the CPU. We have an instruction set. Just like the Intel processors have an instruction set that you can program Microsoft Word or Windows with, we now have an instruction set that game programmers can program to create special effects on our processor.
So that means a game developer is not stuck saying, oh, I can only do what the graphics card will let me do. You can make the graphics card do whatever you want it to do.
That's exactly right. So for the first time, really, in real time, game developers can create essentially special effects.
Yeah.
And so what used to be the domain just of movies and special effects there, which are render farms and it would take hours per frame, we render those same special effects in real time at 60 frames per second.
This is all about what's on the screen. So let's get to the computer here, and I want you to show me a couple examples. First of all, in a game, I mean, you're concerned about the surfaces of things, the texture, the animation. Show us an example. You have a great example, I think, of a chameleon there.
Right. So we came up with this idea of the chameleon to really show off the nature that because it's programmable, it can change the way it looks. So interactively, we can actually demonstrate programmability with this chameleon here. So it's completely real time. I can look at it from any camera angle, any way that I'd want. It's actually being driven.
So this is all being generated and driven right now in real time.
That's exactly right. All this
it's responding to your direction.
Is running on the graphics processor in real time.
Okay. So you've wireframed it, for example?
The first thing, of course, is that the chameleon is built from geometry or wireframe. The animation of this chameleon, how he moves and walks and the skin bends over him, is done with the program. We call that a vertex shader. Okay. That's a piece of code that runs on our graphics processor that drives the way he animates. In addition to that, of course, we have the way that he looks. And so we have a variety of what we call pixel shaders to generate special effects that are on the surface of this creature. And so interactively, we can create essentially the Predator look, where he's actually semi-transparent. He actually refracts the ambient light around him, and yet still reflects it, or bends it into the environment.
And again, to be clear, this is no cutscene here. I mean, this is you are running this.
That's right. If you look at my hand and you look at the mouse as I move it around, it's completely interactive.
Yeah.
We can play with this as we see fit. And if you look at, this is actually our Invisible Man shader to kind of give you an idea what the skeletal system and the vein system look like. We'll go ahead and let the chameleon continue walking here, and we'll talk about some of the shaders. So as we get close, we'll go ahead and zoom in on the surface of this guy. And if you look, just say on the joints of his arm there, the bumps are correct. The way the specular highlights move across the bumps as he animates are all completely correct.
All right. Now, I want you to go to the next demonstration. Another thing in a game is the landscape, the background, the environment. They're often sort of clunky and dull, and they don't really get you into the game emotionally. And you have the ability now to actually generate real-time landscapes too, right?
That's exactly right. Because the processor is programmable, we can actually program the processor to procedurally generate a world. So the advantage here is that where previously worlds would have an end. You could get to the end of the texture or the end of the geometry, and that was it.
So again, this is a real-time generation of this landscape.
Right. If you notice the mouse as I pan it towards the edge of the screen, that's the direction that I fly, and I'm flying around the world. I can get close to the landscape. I can fly up in the air. The other nice thing about this, the world is completely generated, but we've got so much graphics processing power that we can actually have a little bit of fun. So wherever I click on the screen, we have a meteor come flying down, and the meteor does some interesting things. As he clicks and lands, you notice there's that ripple, that shock wave. We do that with a vertex shader. It's actually taking the geometry underneath and deforming it.
And again, you're running this right now. It's
on the graphics processor.
Not just happening.
That's
the
all
last
real
thing
time.
I want you to show us is the hardest thing in a game is the human face, right?
That's exactly
I mean,
right.
there's so much subtlety in the different expressions. Most games, the faces are pretty boring. You never get to know them, right? You have a demonstration here, which is just incredible in what you can do with this card.
Yes, we wanted to create, to solve the problem, or at least attack the problem of creating some emotional conveyance in a character. Today's game characters are kind of blockheads. They have you know, flat faces, maybe moving textures, and typically plastic hair.
So what do we
no
have
hair.
here? Zoltar.
So we've got Zoltar, which is actually kind of modeled after the Zoltar character from Tom Hanks' movie Biggs. He's a fortune teller. And it's a completely interactive face. I can view him in wireframe or not.
Yeah, but go back. Let's see the motion around his. When he talks, I mean, you can see the skin stretch.
We'll move into his face a little bit here.
Mouth,
Get nice and close, and we'll go ahead and fire up an animation here. And you notice that what we can do is program the graphics processor to deform his actual skin. We've modeled the skeletal structure and the muscular structure of his face as programs. We download those to our graphics processor, and we can animate him and move him around entirely in real time. So for the first time in real time, you can get human characters. This is something that even the movie industry has really just started trying to tackle, and now we're running it in real time on a graphics processor.
Okay, so it's NVIDIA's GeForce 3, and it'll cost me how much?
About $399.
All right, thanks a lot.
Great, thanks a lot, Stuart.
All right, well, once you have a killer graphics card in your computer, the next most important element for a great gaming machine is sound. There are many sound cards and systems out there to choose from. Here to tell us about one high-end option is Scott McNeese of Philips. How you doing, Scott?
Great.
Okay, now we have to explain, it's pretty hard to demonstrate this on television because most people are listening to some little monaural clunky speaker on a TV set probably. So they're going to have to trust us a little bit.
Right.
So let's talk about what's the big deal about your new sound card, which is what, the acoustic Edge. Okay.
Yes.
It's a new generation card too. Why?
Yes. Well, basically what we set out to do is when you're in, you know how great it is if you're sitting in a movie theater with really nice Dolby Digital or DTS sound system and you're surrounded by sound, so you just really, really get immersed in it and enjoy it. Well, we want to be able to create that same experience on the PC. The problem on the PC is most of the sounds you hear, music, even most of the sounds in games, are not positional or not 3D.
At best, it's just stereo sound, right?
Exactly. So we came up with a solution in terms of our Thunderbird Avenger chip that we developed and the algorithms that we put on it that basically allow us to take any stereo sound and create multi-channel sound. That is 4 or 5.1 channels of sound, just like in the theater, so it surrounds you.
So even though the game itself is only pushing, say, stereo sound, 2-track sound, you can somehow put an algorithm on top of that and pull that apart into 5 different channels, so I really have surround sound.
Exactly. In fact, there's 2 different cases there. There's some games that have no positional sounds at all.
Right.
And those will make that game all of a sudden a positional 3D or a surround sound game. But even those games that are coming out now that do use positional 3D, they'll only take a portion of the sounds and actually position them, and everything else will be stereo or mono.
So you can actually put more in the game than was in there in the first place, this algorithm.
Additional layers of surround sound, if you will.
You have a nice little demonstration here, actually. If you can show us that sort of visual representation of the way you break up the sound.
Yes, this is an MP3 player that's included, and there's going to be a visual here. I'm going to start it up. And first, actually, we're going to start it in stereo. And you see these 2 little visuals here. That corresponds to a left and right speaker.
Okay, so that's the 2 tracks that are sort of pushing out the sound right now.
Right, exactly. Now, I'm going to go to
that would be our typical stereo environment.
Exactly. Now I've gone to 4 speakers, and this shows...
Now, how did you go to 4 speakers? You just told your card I went 4.
Exactly. I said, let's assume we have a 4 speaker set up with this, and let's go to 4. And if you look at this, you can see the 2 front left and right, and the left rear and right rear are very different signals, and you can actually hear it. So all of a sudden, you're hearing different sounds from every speaker.
Right.
Now we're going to take it a step further. Let's say you have a...
You said 5.1. How's the 10th of a channel?
Yeah, it's actually terminology that comes from movies, DVD and DTS. The 0.1 is a low frequency effects channel. It uses basically a subwoofer to do that. And that's that center channel right there. And this one right here is the center channel, which is also added. And that makes the vocals in a song or the vocals in a game or a movie come out very clearly from the front of you, while other sounds will come from all the different surround speakers.
All right, so we're talking about gaming here. So I want you to pull up a game just as a demonstration here. I think you have the game Forsaken up there, which is one of those games with lots of stuff going on around you. And it'd be great to have the sort of 5-dimensional sound you're talking about.
Absolutely. It's like playing with a whole new game all over again. If you've been listening to it in stereo, and you listen to it this way. Yeah, this game actually came out a few years ago from
Right.
Probe, and it's put out by Acclaim Entertainment. A very, very popular, very good game. Graphics were excellent. But it's a good example of a very good title, but that is stereo only.
So let me explain again. We've got 5 speakers around us here, so I mean, there's no way we can just translate that through the television set. But I mean, just go through the game and actually explain what's going on in terms of the spatialness of the action.
Okay.
You know this game?
Oh, yes.
Okay. This is actually a demo version.
Right.
I'm not going to ask you to
This
play
is a
it.
pre-recorded session. This is true gameplay, but it's a pre-recorded session. It's going to start up in a moment. And what would happen if you had another sound card product that did support 4 or 5-point channels is what they do is, if they only have stereo, they play the same thing out of the rear channels as the front channels.
Okay, so you're not getting more...
You don't get anything more, and
more realism out of it.
It's almost the equivalent of playing mono out of a set of stereo speakers.
You're
It's still
two
mono.
mono tracks, right?
Yeah. So as you're going along here now in this spacecraft and you're firing, because of this algorithm basically creating the 5.1 channels, all of a sudden the explosions...
So we can hear it behind us, in front of us, to the left, to the right, so you're really immersed in the game.
Yes, it's almost like an interactive movie, and with the graphics you were just talking about, the combination of the graphics and the audio really can make it an interactive movie, an experience that you can really escape into. Absolutely.
All right, now, while we continue to look at this, one question. If I look at my computer in the back, I got one little jack, to plug in the speaker, and you got 5 or 6 speakers going here. How do I do that?
Okay, yeah, well, on our sound card, we actually have a special adapter, so we only take up
we do
one
have the
slot.
card here, actually, so this is what we have here.
This top jack here, it's called a DIN-style jack, and it comes out and it actually gives you 3 stereo jacks, so you get all 6 channels, the 5-point channels. The second one here actually allows you also digital in and out, so you can also do digital interface with things, and you can even pass AC3 or DTS information if you have a surround processor externally.
Okay. Now, last question. The card's great. You need great speakers to go with it. You have some interesting technology there. I want to ask you, first of all, about this guy over here, which is your WUX speaker. What's the new technology inside here?
Yes, it's a technology we actually developed. We actually make speaker technology for a number of the car manufacturers around the world, and the problem there is when you get into these high-end sound systems, you want a really big bass.
But you don't have the space for it.
Exactly. And because basically with a subwoofer, the bigger the box, the bigger the sound you can get out of it. So what we've done is, this has a down-firing driver that you can't see on the bottom of this. It's the active driver. But this is the key to the technology. It's a membrane that can move very far.
Big-time mega bass coming out of a small box.
It basically, it fools it into thinking the box is much bigger than it really is.
Briefly, how much is it going to cost me to set up the sound system?
Okay. Well, the card itself, the one we're showing here, is $99.99, but we actually we're introducing 2 new products. We'll actually take a 4-channel all the way down to $49.99. In terms of the speaker systems, we have 4 and 5.1 channel speaker systems starting at $80, and this one here going up to $199.
Thank you very much. All right, coming up next, the new Pentium 4 chip. How much better will your game run on a 1.7 gigahertz CPU? We'll see in just a moment. Well, you can have the best graphics and sound cards in your computer, but underneath it all, you still have to be able to process the bits fast enough to drive everything. So how important is the speed of your CPU to great gameplay? Well, let's find out now from Tim Thraves of Intel. Hi, Tim.
How you doing?
And your new bit is the P4, the Pentium 4, obviously, and you've got, what, a 1.7 gigahertz chip we're going to look at here?
Yep, we're at speeds up to 1.7 gigahertz on the Pentium 4.
Now, we hear that a game's been optimized for the P4. What does that mean to me?
Well, bottom line, it's going to be better or faster gameplay, but that could show in terms of more realistic environments, smooth gameplay and animation. Basically, it's writing to the advances that you see in the Pentium 4 processor today.
All right, you have a couple of examples here. Let's take a look at some games to sort of demonstrate the things you're talking about. This is a game called Giants, and what should we pay attention to here that we say is the result of running this thing on a really fast processor?
Sure, so some of the things you definitely look at first is the trees. Notice how they're actually blowing in the wind.
Yeah, that's cool.
You know, this is definitely something that in older, prior generations you wouldn't see. It would have been a static tree that you don't see at all.
Okay.
You see the realistic lighting effects. You see that the water looks pretty realistic compared to water of a couple years ago.
And the motion of the character there is pretty smooth.
Yeah, and you can also see different camera angles of the actual player. So, so let's look around and see if we can see some other creatures here.
And obviously you can have a lot of stuff going on at the same time.
Absolutely. That's the key, is especially when you're playing online games with multiple players. smooth gameplay, no drop frames.
All right, let's go to another one. You have another game up here on the other drive, which is called Colin McRae Rally. This is a racing game, and that is probably the most demanding kind of game, right? Because you got a lot of stuff changing very quickly.
Absolutely one
And
of
if it's not realistic, it's a waste of time.
Absolutely. And this is one of the newest games out there. Again, this has been optimized for the Pentium 4 processor. So what you're going to see is, again, smoother animation, very realistic gameplay. One of the coolest things is that, you know, when you get damage on the car, it actually looks like damage. It just doesn't.
Now, another issue in a game like a racing game is there's physics realism, right? I mean, you want the thing to work the way things really work in the real world, and that's a function of what you can do with the processor.
Absolutely, absolutely. So let's see if we can get a fun game on here. Let's see, we'll play in Sweden.
You have the 10,000 choices here.
Yeah, multiple choices in terms of what you can do.
All right, so we're racing in the snow here.
Right. So what we can do here is, you notice,
and it's laying down tracks in the snow, so that's pretty cool right there.
and just to prove it is, that's not my normal driving style. So what you're going to do here is, again, this is a pretty realistic game in terms of just driving it. You know, as you're driving on snow, it's not just turn and.
Gotcha. And so when you crash, which of course everybody wants to do in a racing game, you're going to see the real dents and the bumps. And
Absolutely. So the other thing to notice is here is you can also look at it at different camera angles, and depending on which angle that you're most comfortable playing with.
Yeah, that's a good point. Now, if you get at this angle, this is really more demanding on the CPU, isn't it?
Absolutely, because everything's much closer, faster.
And it's still going very smooth.
Especially.
All right, I want to get another game in here, so you can stop that and let me change CDs for you, because there's one other example, a game called Can I pop it?
Absolutely.
A game called Sacrifice, which is really a good example of a new feature you've got in the P4. So let's get this baby up.
Absolutely. So again, Sacrifice was one of the first applications really to appear optimized for the Pentium 4 back in the end of last year. So let's start this up.
Now what we're going to see here while we get the game up is that the problem in a game often is you see an object in there, and as you get closer to it, it gets pixelated, it gets worse, it degrades.
Absolutely.
And you're now able to actually not only stop that, but reverse it.
Absolutely, and one of the technologies in this application is a technology that's called multi-resolution mesh. And what it does is exactly as you described. As you get closer to objects, instead of pixelating, it actually becomes clearer and crisper, which is what you would expect in real world.
All right, so let's get into this
Let's
game
load up
here.
a game here.
So the game's called Sacrifice.
Yeah, from Shiny Entertainment. And what you're going to see here is right away we're loading it up into a scene that's very high resolution, lots of things going on, as you can see. There's rain, several different things flying
Now
around.
find an example of this sort of MRM bit where we can get close to something and see it get more detailed rather than degrade.
Right, so let's take a look at either of these documents over here. Turn around. So what we're going to do is we're going to walk, as we get closer to these environments.
So even the tree, as we see, we got close to the tree, we saw more graininess in it rather than less in terms of the roots and so on.
Right, so you see right there, you can actually see that. It's much closer and better as you get closer to the object, was actually exactly opposite from what previous generations game were able to do.
All right, last question I would have for you, Tim, is we hear the numbers, 1.7 gig versus whatever. Say I've got a 500 megahertz Pentium 3 right now. How much faster how much better performance will I really get out of it? It's obviously not going to multiply by 3 or 4, am I?
Sure. What you're going to notice is that in most applications, especially gaming, you're going to see anywhere from 2 to 3x of the types of performance. For example, in one application we know for sure, in Quake 3 Arena, we're seeing about a 3 to 4x performance gain. And just going from a Pentium 3 500, which gives you about 50 frames per second, on the latest 1.7 gigahertz Pentium 4, you're getting almost over 200 frames per second.
Tim, thank you very much. Thanks. Well, you may think this is just all too complicated. Upgrade this, upgrade that. Maybe the best solution for a great gaming computer is just go buy one. Well, here to give us some advice on the ultimate gaming PC are Will Smith and Gordon Ung. They just wrote an article, in fact, for their magazine Maximum PC about the great gaming computers that you can put together out there. Let me ask you, first of all, Will, we've got two machines over here. That is a Falcon Northwest.
Yes.
This is an Alienware. Just explain what's the big deal about going to a company like Falcon that specializes in putting together gaming computers?
Well, Falcon is a bunch of gamers that basically they play games and build computers. So when you call and say, hey, I play Microsoft Flight Simulator or I play Quake 3, then they know exactly how to tailor a system to fit your gaming needs.
All right, so you've already got your games. This is what I want to play. Make me a computer, put together some hardware that'll give me the best possible game experience?
Exactly.
Exactly. Now, what is it about it, though? I mean, one thing we can see is a lot of fans blowing in this thing. In fact, we can hear them. That's so if you want to mess around with the clock speed of your processors.
You can overclock your video card,
Right.
a couple of notches to get it, that extra 5 frames a second, or your
Right.
processor, whichever you see fit. They add more than sufficient cooling for everything. That's
And
in
what
the
particular
system.
graphics card do we have in this one?
This is the Hercules Prophet 3, which is a GeForce 3 based video card with programmable pixel and vertex shaders
Okay.
and all that cool stuff.
Now, there's this strange green monster over here from Alienware. Is this just like cool style, Gordon, if you want this to be?
Well, I think for the Alienware and also for the Falcon, gamers are hardcore PC people. They want people to know that they have pride in their ride. They don't want a Ford Taurus beige box. They want, a Dodge Viper.
It's got to stand out.
It's got to stand out. You bring that to a party, or a LAN party, which
Yeah.
a lot of game people do, and people are going to give you some looks.
Yeah, and we don't have the monitor here, but the monitor's green, the keyboard's green, the mouse is green, the speaker's green. It's a different look. All right, let's go to the performance of this thing over here, if we could, Will. We have a couple demonstrations up here. First of all, the game called Black and White.
Right.
I want you to run the game off the Falcon and show us what is it about the game that demands a lot from the hardware.
Well, if you look at this game, it's a God-type simulator game. You can see everything, manage everything from the island level, this huge 500-acre island, all the way down to the individual people in the villages on the island. So we'll zoom in and take a look at the villagers here. And here's the nursery area of the village with all of our people in it. Each of these people is, I think, 800 polygons, somewhere around
And
there.
a lot of them running around. There's a lot of different things going on at once. It's all relatively smooth. The detail's pretty good.
Exactly.
So, I mean, again, if you're the hardcore gamer, you want the realism, you want the frame rate, you want just everything to be absolutely maxed out. All right, now you have another example, which is even better than that one. It's sort of a benchmark test of a sort of scene that is just really incredible in terms of what you can get out of an optimized game machine. And pull that one up, Will.
Exactly. This is from 3D Mark 2001. It's the nature demo. And it's basically, it's a DirectX 8 game. It requires a DirectX 8 compatible accelerator like the GeForce 3. And it's what we can expect to see from games in the next year or two.
I mean, this looks like you're looking at a movie. I mean, an HD TV movie in a way, right? I mean,
Certainly. It uses all the pixel and vertex shader effects that the GeForce 3 offers to do lighting on the water, as well as some interesting effects with the trees.
let me ask you about the trees. If we can see another scene, I mean, we see the leaves waving and all the branches going in different directions. I mean, it looks so realistic. What's it take to do that?
Well, the cool thing about the trees is that the leaves are two-sided polygons, which means that each side of one polygon is textured with a different texture, as opposed to the old way of doing it, which is put one texture on a polygon and slap another polygon on the other side to texture it. And that lets the light shine through the trees and the leaves on the trees and look realistic.
Yeah, so you get, I mean, the real lifelike experience. You put together the graphics, you put together the sound, you got
It's
a
the
real
total
game
package.
going. Yeah. Now, does it cost me more to do something like buying a Falcon or an Alienware?
I think this Falcon is right around $3,500, which is a little bit more than a comparable
What kind of
Dell.
processor?
This is an Athlon 1.3
Okay.
gigahertz processor, but you get a lot more service with the $3,000.
So if you call up in the middle of the night and you're having trouble with your game, these guys are going to say, whoops, we don't deal with games.
No,
They'll know what you're talking about.
They'll know exactly what you're talking about. They'll say, oh, well, to get Quake 3
Yeah,
to run, then
gotcha.
here's what you need to do.
All right, Gordon, last thing I want to talk to you about is this laptop over here. If you use a laptop, you're kind of stuck when it comes to playing real games, right? Because you just can't support it. This is a Dell Inspiron 8000. What is it about this machine? You say this is the only laptop you could really play a game like Quake 3 on.
Right. The reason this Inspiron is so great is because it's one of the first notebooks out with GeForce to Go.
Yeah, let me just sort of run it here a little bit so we can see what's going on.
Which is basically a little brother to the GeForce 3.
So the big deal is it's got the big-time graphics card in there, so
Right.
you can really look at a game like Quake.
It also has a 1 gigahertz Pentium 3 processor in a notebook.
Okay.
This notebook is probably faster than most of the machines that were made last year.
So you might get better gameplay off this laptop than you could off a lot of desktops right now.
Right.
Because of the combination of that graphics card, CPU, etc.
Yep.
Okay. Thank you very much. So it's worth going out there and buying a real gaming PC if you're a gamer.
Certainly.
Thank you, guys. All right, that's our look at building the ultimate gaming computer. Don't go away. I'll be back in just a moment with my pick of the week. Now for my pick of the week. I used to travel with a small portable CD player. Nice to have some music with you on the road, especially if you don't have time to rip your CDs and organize your MP3 player. But that's all it did, play music. Now I have discovered this little gem from Sony called the Digital Relay. It's about the same size as my old CD player. It weighs less than a pound, but this is more than a CD player. It is a battery-operated CD burner that can burn CDRs or CDRWs. And it's more than a traditional CD player. It can also play CDs with MP3 files on them, since it comes with an integrated MP3 decoder. That means with just one MP3 CD, you can carry around up to 11 hours of music. The digital relay comes with a nice suite of software for burning and organizing your CDs. It also includes software that makes it easy to use the drive for data backup or as a portable storage device with infinite capacity. What's really cool about this is you can easily burn a presentation CD for a client while you're on the road with photos, music, videos, whatever, and you're not carrying around much more than you would with a plain old CD player. The digital relay comes with a rechargeable lithium-ion battery that lets you burn 2 hours on a single charge, and since it can record at 4x speed, that's the equivalent of burning 8 hours of music on one charge. And it features an 8 meg memory buffer, so you can record reliably, even off a slower computer. It connects to your PC through the USB port. It's called the Digital Relay from Sony. It works with a Windows PC or a Mac, and cost is under $400. That's it for this week's Computer Chronicles. Thanks so much for joining us. If you have any questions about anything you saw on this week's show, please check out our website at computerchronicles.org. Hope we'll see you here again next week. Computer Chronicles is made possible in part by PC to PC, the online computer migration service from PC First, moving files, applications, and preferences from your old computer to your new one. Additional support is provided by Upside Events, presenting the Digital Lifestyle Revolution Conference, where people and technology intersect.
To purchase a videotape copy of today's program, call toll-free 1-888-310-7850. Please specify the show number and the topic.
Next week on the Computer Chronicles, the battle between the PC and the TV. We'll show you how to surf the net on your television set using AOL TV. We'll demonstrate the coolest new box from Microsoft called Ultimate TV. We'll show you the future of e-commerce. It's on your television set. And remember the Mosaic web browser? Well, it's now the Mosaic Navigator for your television set. And the future of entertainment on the web will show you TV quality movies on your PC. The battle between the PC and the TV, next week on the Computer Chronicles.